Okay, well, I wanted to just follow up on a few things that I realized I left out of the previous lecture. So I demonstrated a lot of these transformations, but I didn't show how you would do it. I think I'd discuss it in the homework, but I want to go ahead and discuss it now. So, how do you plot the parent function and then plot the transformation? And we're talking mostly here about um, translations and reflections. The stretching and shrinking is more of a thing that's useful when we get into trigonometric functions. So I'm not going to dwell on that at this point. I'm just going to emphasize translation and reflection. So let's get a piece of graph paper, and I'm going to go through each function and show you how you can plot these. And let me see. Okay. So let's talk about the quadratic function. So to be able to plot this, and it'll be on a similar kind of scale that we're seeing here, what we want to do is make up a table, and we'll have x and y values. And we want at least 5 points to plot. So we'll have this size table, and we'll have x and y. So these are the coordinates for the parent function. So we'll go -2, -1, 0, 1, 2. Okay, so the function is x squared. That's our parent function. So if you calculate the y values, you'll get 4, 2, 4, 1, 0, -1, 1, and 4. Okay, so if we want to plot this on this graph, and we'll use the scale that we've been using a lot. So if you plot these points, you go to -2, +4, -1, +1, 0, 0, +1, +1, +2, 4. Now you could include 2 more points, which would be 3, 9. 3 squared is 9, and -3 squared is 9. Okay, so from that, those at least 5 points, even 7, but we'll just say 5 points, you can draw a reasonable parabola. Even if I didn't have these, I would still have a pretty good parabola, and I would, approximate how this thing goes up here. Okay, so there's my rough parabola. Now, if you have a translation, let's do a function with a translation. So I'll have x plus 2 squared plus 3. And so from what we know so far, we know that we have an x shift of -2 and a y shift of +3. So we can change the vertex of this from 0, 0 to -2, +3. So that puts me right there. Let me use red. So that's my new vertex. Now what you have to do to plot your new parabola is you just have to draw these other 4 points relative to this new point. Now one thing you could do is you could put in a, like a new x-axis. It's kind of a pseudo x-axis, pseudo y-axis. And then you could plot these relative to that new point. So at this point, you go over 1, up 1, over 2, up 4, 1, 2, 3, 4. So these are all relative to this new anchor point, we called it. The one here, -1, +1, -2, +4, 1, 2, 3, 4. So you just have to do counting. And then you got those 5 points, the new vertex, and the 4 additional points. So that's how you do it. And that's what I'm expecting you to do. I don't want you to just find the new vertex and just kind of haphazardly fill in the points. Now, if you had a reflection, say in this case, the only reflection that's really useful is the one across the x-axis. If I had a negative sign in front here like that, you'd still have the same vertex. You still have this point, but instead of going up, you go down. So here I went over 1, up 1, you go over 1, down 1. Instead of going over 2, up 4, actually I didn't do that, did I? I went up 3, 4. Okay. So you go over 1, down 1 instead of up 1, over 2, down 4, 1, 2, 3, 4. Then you go the other way, over 1, down 1, over 2, down 4, 1, 2, 3, 4. Okay, they're all matching up this time, and then you can sketch that in. So I want at least these 5 points for parabolas. Okay, let's look at the square root function. Now, for the square root, you're not going to need as many points because we're not going to have as much of a, since we don't have any negative numbers in the domain for the parent function, we don't need to have -2 or -1. We really only need 0, 1, 2, but let's go ahead and include 3. So I'll need this, 1 row, 2, 3, 4, 1, 2, 3, 4, 5. So I need this thing to be 5 by 2. Okay, so that's going to be my table of points. So again, you have x and y. We're having a 0. We're going to have 0, 1, 2, 3. Actually, no. What we're going to use for the square root function, we're going to use 0, 1, 4, and 9. And the square root of these numbers is 0, 1, 2, and 3. We're just doing it so we end up with integers. Now let me get a piece of graph paper. So we'll plot those 4 points in this case. So you have 0, 0, 1, 1, 1, 2, 3, 4, 2, 9, 3. I mean, a square root function is pretty much like a parabola, except it's rotated around. So that's the function, square root of x. So we have 1, 2, 3, 4 points. Okay, so you need to plot those exact points. Now, once you have the parent function, you have the position of these points relative to the origin. And what we'll do is when we have a translation, we will move that origin and we'll shift these other 3 points appropriately. So we can see we go over 1, up 1, over 4, up 2, over 9, up 3. So let's do another one here. So let's do the square root of x minus 3 plus 2. So the translations we have. Okay, so what we'll have is a translation. We'll have an x shift plus 3, y shift plus 2. So what that does is it shifts this origin point. So we're going to go plus 3 plus 2. So there's our new point, which corresponds to the origin. And then we're going to plot the other points relative to that new origin. So we said here the parent function, you went over 1, up 1. So we're going to go over 1, up 1. The next one was over 4 up to, over 4 up to. Now the fourth point is off scale, so we're not going to do anything about that. And so we have something that looks like that. So that's our translation. Let's do another one. So we'll translate it the other direction. So let's say f of x is equal to the square root of x plus 4 minus 3. Okay, so here we have an x shift of minus 4 and a y shift of minus 3. So we take this origin point, 0, 0, and we go negative 4 in the x direction, negative 3 in the y direction. So we get that point. These 2 points correspond. And then we draw the other 3 points relative to that new point. So we go over 1, up 1, over 4, 1, 2, 3, 4, up 2, over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. And the next one would be 16, 4, which that would be still off of the screen. So we get something like that. So this function that I'm showing here is the square root of 4x plus 4 minus 3. Okay, let's do one with a y-axis reflection. So what I'm going to do is just write another function down here. So we'll do, so y-axis reflection would be something like this. There'd be a negative sign in here. And I'm going to put minus 2, minus 3 outside. Now remember, anytime you have a negative in front of the x, you have to factor out the negative out of both terms inside the argument. So that becomes negative the quantity x plus 2. So this is saying we have a y-axis reflection, and this one says that we have an x translation of negative 2 and a y translation of negative 3, or shift. So we'll say the x shift is negative 2, and the y shift is negative 3. Okay, so we come over here to the origin, and remember that we do the reflections first. So what the reflection across the y-axis does is it's going to mean instead of going to the left one, we go to the right one and go up. We go to the left one and go up. Instead of going to the right 4, we go to the left 4. 1, 2, 3, 4, and up 2. And instead of going to the right 9, we go to the left 9 and up 3. So this curve here is just f of x equals negative the square root of x. Then what you do is you're going to shift the origin by this amount, which is negative 2, negative 3. So that's that part. And these 2 points again correspond to each other, but instead of making this go to the right, we make it go to the left. Again, the same relative distances. So we go left 1, up 1. Left 1, 2, 3, 4, up 2. And 9 is going to take us off. So this would be our curve. So to make sure we have at least 3 points, and we know this is not going to reach here. This is it's not going to reach this next level until we get off the screen. So we don't want to have this thing cross if possible. We know it's going to be somewhere between up 2 and up 3. Okay, so we've done the quadratic function, we've done the square root function. The cubic function is, it's the same deal. Okay, so before we move on to the next topic, I just want to make a correction. In the previous one, I said that this was negative the square root of x, and that is incorrect. It should be the square root of negative x. So the negative should have been inside the square root. So fix that on your notes. This would be negative the square root of x, where we have an x-axis reflection. Here we have an y-axis reflection, so the negative sign should be inside there. I apologize for that. I'm trying to remember if I've ever put a cubic function on a test. What you'd have with a cubic function, which is what we're talking about, the parent function, would be y equals x plus 2 cubed minus 3, something like that. And so the parent function, you can actually only get 5 points the most. I think, actually, yeah, 5 points. So you'd have x versus y, and you'd do negative 2, negative 1, 0, 1, and 2. Negative 2 cubed is positive 8. Negative 8, sorry. Negative 2 cubed is negative 8. That's negative 1. 0, that's positive 1, positive 8. So if you plot that, so the parent function is going to be negative 2, negative 8, negative 1, 0, 0, 1, 1, and 2, positive 8. And it's really, it's very close to the y-axis for this scale. Now you can see if I don't have to move it too much vertically before I shift one of these points. Either this one, if I shift it vertically, this one's going to go off. And if I shift it negative vertically, this one might go off the scale. So we may only have 4 points left after we've shifted it some. So you got to be careful that you don't. You just got to remember this one is a lot is happening close to the origin. So let's do 1 here. So if you had x minus 1 cubed plus 2. So again, you're going to have a x shift of plus 1, and you're going to have y shift of plus 2. So you move the origin point, this point right here, 1 unit in the x direction, 2 units in the y direction. Again, these 2 points correspond to each other. So again, you have to do this relative movement. These are the numbers, the changes relative to the new origin. It's not really the new origin, but it's where the function is symmetric around. So this point here, 1, 1, you move 1 to the right, up 1. For this one, you move 2 to the right, 1, 2, and up 8, which would put you right there. Now you go the other direction, so you go left 1, down 1. That corresponds to this. Left is negative, down is negative for the y. Then you go left 2 and down 8. So you'd go 2, 3, 4, 5, 6, 7, 8. So you'd have 5 points. And then you could draw those in once you have those 5 points. And you have your original parent function and you have your transformed function. Now if you have either y-axis or x-axis reflection, you just have to switch these around. So instead of going over 1 and up 1, you go over 1 and down 1. Instead of going left 1 and down 1, you go left 1 and up 1. And so everything gets flipped around.